Hi lads. Today I just want to start with a little bit of um, stuff to do with time, right? And how to do the time on your calculator. So I'm going to see now if I can show you me working live. Yeah, hopefully this is going to work that you can see what I'm doing here. Now, okay, do you see my calculator here, right? So this is one of the new ones now, okay? Casio, only the finest. The finest calculator out there is Casio, in my opinion, as you know. Now, do you see the sun's coming there, right? So see this one here, right? That's your time button, okay? Don't ask me what it is now in the sharp. I'm only talking Casio here. So let's say I want to say, what like, um, 25 past 4, right? If I'm going to go 25 past 4 in the calculator, I'm going to show you how you do it. So what you do is you put in your bracket and you go 25 past 4 and 24 o'clock is 16 degrees, 25 minutes. Wait, I'll show you what that looks like. 16 degrees, 25 minutes. And I'm going to say, let's say I want to know the difference between the time between 25 past 4 and 10 past 2. And let's say I didn't know what to do it in my head. So then I'm going to 24 o'clock. I'm going to put in, oh, I think I made a mistake there now. It's hard to actually record all the same. Press the degrees, 14 degrees, 10 minutes. Close the bracket. Hopefully that's looking right. It is. See, every time I put in 14, I would then press the button for degrees 10 and then the minutes is going to come up. I'm saying degrees, lads, because that is the sign for degrees. Is how it comes out. And all I'm going to do now is press equals. And you see that this tells me that the difference between the time between 25 past 4 and 10 past 2 is 2 hours, 15 minutes, and 0 seconds. That's how you read it. So that's actually very handy now when it comes to speed, distance, and time to do it. Like, especially if you're one of those people that always found the clock back in primary school, you found that difficult. Don't worry, Casio's here to save you, and this is how you do it. Okay, right, that's grand. So let's say I'm going to cancel out that, and hopefully that works. And now what we're going to do is we're going to look at a couple of the ratio questions on the chapter 12 of the Text and Test 2 book. I suppose what we might do is we might look at speed, distance, and time, and then just a tiny little bit on ratio. So what I'm going to look at is question 10, and if you have the Maths Text and Test 2 book at home, it is question 10, page 295. Now, you can have a read of it there now and pause it. Right, so what we need, lads, is, first of all, which is very, very important in all of this, is that you need to know this triangle off, okay? And you come across it in science as well. So it's this one, speed, distance, time. They're asking me for the total distance. They're asking me for D. And D equals S multiplied by T. So to do double I, all I'm going to say is, well, the first part of the journey was speed was 90 kilometers per hour for 2 hours. So 90 by 2 equals 180 kilometers. The second part of the journey was a further hour at 60 kilometers per hour. So that's 60 kilometers by 1 hour, which is 60 kilometers. So my total distance travelled then is 180 plus 60, which is 240 kilometers. The total distance travelled is 240 kilometres. Total time taken, lads, is very simple. It's just going to be like you have 2 hours in the first part of the journey and the further hour, so that's 3 hours. And then to get the average speed, then of the whole journey, speed is distance divided by time. The total distance travelled is 240 kilometres. The total time taken is 3. So the average speed is 80 kilometres per hour. Now we're going to look at another one just to do with speed while we're at it. Let's say we look at this one, question 18 on page 295 of the book. Pause and try it first of all yourself. I'm asked to get the total time. Again, you know what I'm going to do? I'm just going to draw my little triangle. Speed, distance, time. They're asking me to get time, so it's going to be distance over speed. And for the two journeys, the total time taken. So I'm going to do part A of the journey first of all. It was 15 kilometers over 6. That gives you 2.5 hours. You see, it's in kilometers per hour, so your answer is going to be in hours. Part B of the journey was 9 kilometers with a speed of 18 kilometers per hour. So again, time is distance. Time is distance divided by speed. So the distance is 9 over the speed, which is 18, which is 0.5 of an hour. Therefore, my total time taken is 3 hours. I just add 2.5 and 0.5 together. And as I'm about to rub that away, so pause the video, you need to take it down. Okay. Then his average speed for the two journeys. So average speed is distance divided by the time. The total distance, as you can see, was 24 kilometers. Over the total time taken, which was 3 hours. So his speed is 8 kilometers per hour. And that's it. That's the only other one that you see there in speed, distance and time. And was there anything else then? Did we do this one already? I think we did we? No, maybe we didn't. How about this one, question 5? Question 5, yeah, page 294. Have a read, pause, try it yourself first of all. Okay, find how many litres of petrol were used. So if his car had an average fuel consumption of 1 litre of petrol per 15 kilometres, they're saying that if every time the car does 15 kilometres, 1 litre of petrol is used by the engine. They're talking distance here, okay, when they're talking about that. So I need to know what the distance was for the entire journey. And I do know that my little formula here is SDT. To get the distance is speed multiplied by time. So it's 60 multiplied by 2.25 hours is 2.25 of an hour. 0.25 is quarter as a decimal. And then 60 multiplied by 2.25, that's 135 kilometres that motorist has travelled. But every time the motorist did 15 kilometres, a litre of petrol was drained using the engine. So like what I'd love to know is if I was in that journey, oh, like, God, I'd need to know like how many 15 kilometres are in 135 kilometres. Because that's when I know I need to stop at the garage. So 135 divided by 15. Right. For that journey, I'm going to need 9 litres of petrol. That's it. Didn't ask you to do anything else. Simple out. Final thing, lads, we're going to have a look at. I'll just take that away. It's just a tiny little bit in ratio and it's not going to take long. I just need to check the timing on this device. Okay, I've got 8 minutes. That's grand. Now, so we're going to go back up here. It's all we need is here is on question 11. So question 11, lads, page 295 of the Text in 2 book. If you're ready, let's go. I want you to try it yourself first of all. Pause the video, try it. Other than that, here we go. Okay, so first of all, the minute you see ratios, this is what you do. 1 is to 3 is to 5. That is 1 over 9 is to 3 over 9 is to 5 over 9. So all I did is I added 1 plus 3 plus 5 equals 9. Okay, now what I've got is copper, tin, zinc and tin. So again, it's not very easy to see here, but if I just put it, this is supposed to be copper. Whoops, sorry. This is supposed to be copper. This is supposed to be zinc. This is supposed to be tin. All right. Now, there are 45 kg of tin in the alloy. The alloy is a mixture of metals. There's 45 kg of tin in this alloy. And we know that 45 kg is represented by 5 over 9 in the ratio, isn't it? Yeah, so 5 over 9 equals 45 kg. In fact, then if 5 times over 9, 5 times 1/9 is equals to 45 kg. What you always do, lads, is bring it down to 1 over 9. 1 over 9 equals what? So like 5 times 1 over 9 equals 45. So that's the case. Divide 45 by 5 there, and that'll give you 1/9, won't it? So 1/9 is 9, 9 kg. The question is asking you find the total mass. So now I'm going to just go again. I have copper, zinc and tin. I know 45 kg is represented by tin. I got 1 over 9 just above, so 9 kg is represented by copper. I have 3/9 for zinc. You could simplify that down if you want. I'm going to leave it as it is. Well, 1/9 is 9 kg. Well, 3/9 is just 9 multiplied by 3, which is 27 kg. I'm not finished. They're asking me for the total mass. So the total mass is 9 plus 27 plus 45. And you just add all them up. The total mass is 81 kg. Now, the only other way they can show you this is, let's say, for example, as they say, okay, let's say they say copper, tin. Oh, I don't know, I did a different one, right? And let's say it again, they go 1 is to, oh, let's say 1 is to 4 is to 5, okay? So that's going to be then, right? And let's say they say there's 200 kg of mass in the alloy mixed together with all the metals. This is the total mass, right? So if they said to you, this is the simplest way they could ask you, how much copper, how much tin, how much zinc is present? Now that's going back to first year maths. I'm not dwelling on it here, but that's a simpler way it could be asked. So you get like 1/9 of 200. And when you do that, I don't think that's going to come out to be a round number. Let's do that. 22.222. Okay, it goes on. Well, if 1/9 is that, so there's 22.2 kg of copper, let's say. And then 4/9 then would be 22.2 kg times 4, which would be, wouldn't it be just times 4 that there? And it would be 88.88 kg, let's say, of tin. And then obviously the same, then you go times that by 5, 22.2 kg times 5 would be so the only thing, 101 kg, let's say 111 kg. So the only difference here is how it's being posed, lads. They might just give you a ratio and give you the total mass of something or the total prize fund. That's simple. That's the one you're looking at there. Or what they might do is they might give you a part of the prize fund or a part of the ratio, and you're asked to get the total mass. So there are the two ways. So just be very, very careful in how it's asked. And that's about it on ratios, lads. It's so, so simple.